Have you ever wondered why some planes can fly upside down? And is it even safe for them to do so? This ability seems to defy gravity and intuition, making it a fascinating topic to explore. So let's dive in. Imagine you're sitting in your car, driving around a tight corner at high speed. You feel the G-forces pushing you into your seat. Now, what if someone could turn that car completely upside down, so you are on your roof and still keep you safely inside? That's kind of what inverted flight is like for planes. Planes can fly upside down because of their specially designed wings and powerful engines. The wing shape is crucial. It's essentially designed to work in reverse when the plane tips over. And pilots use a technique called negative GS, where they pull the aircraft into an inverted position, using the engine's thrust for lift. But here's the thing, flying upside down isn't just about defying gravity. It's also incredibly rare and often done for acrobatic performances or testing purposes. Commercial airliners don't typically fly this way because their pilots wouldn't need to perform such maneuvers as part of their daily routine. And yes, inverted flight is safe. The wings are designed with a special curve called an airfoil that can generate lift even when the plane is upside down. Additionally, modern planes have robust safety systems and well-trained pilots who ensure everything stays under control during these inverted flights. So, next time you see a plane flying upside down, remember it's all about the clever design of those wings. And don't worry, they're incredibly safe. Alright, so let's dive into how planes can fly upside down. First off, we need to understand a bit about aerodynamics, how the air moves around that wing of yours. Now, imagine you're holding an umbrella in the rain. When it's raining straight down, water hits the inside of your umbrella and gets pushed out, making an area with lower pressure on the outside. That's kind of like what we see under a plane's wing. But here's where it gets really interesting. When air moves over a wing, something similar happens. The wing is shaped in such a way that air moving over the top has to travel faster than the air below. This difference in speed creates an area of lower pressure above and higher pressure below the wing, which pushes the plane up. This phenomenon is called lift. Now, here's the surprise part. This isn't about the direction the wings are pointing at all. It's how fast the air moves over and under them. So even when a plane flies upside down, the air still has to move faster over the top of the wing than below it, creating that same area of lower pressure above and higher pressure below. Just like when you flip your umbrella upside down and rain still drains out from the bottom. That's why planes can fly upside down. They're just making sure the air moves in a way that creates lift no matter which direction they point. And here's the surprising part. The angle of attack, or how the wing meets the oncoming airflow, is crucial. Even when flying upside down, the wing can still produce lift if the angle of attack is within a certain range. Imagine you're holding a piece of paper by one corner and tilting it to create a small angle with your hand. When you wave your hand forward, air flows over both sides of the paper. The air that travels faster over the top surface causes a drop in pressure, while the slower-moving air underneath creates higher pressure. This difference in pressure is what makes the paper lift up. Now think about an airplane wing. It's shaped like a flattened version of your hand, with a curved upper surface and a straighter lower one. When the plane flies right side up, the wing tilts to make that same angle with the airflow. The faster-moving air over the top causes a pressure drop, while the slower air underneath creates higher pressure, lifting the wing. But here's the key. Even when flying upside down, the wing can still create lift if you adjust its angle just right. It's like flipping your hand and tilting it so that the paper is now facing backwards. The airflow still meets the wing at a certain angle, creating the same pressure difference, but in a different orientation. So, whether the plane is flying right side up or upside down, the pilot can adjust the angle of attack to control how the air flows over and under the wing. By doing this, they ensure that lift is generated, keeping the plane aloft no matter which way it's pointing. But flying upside down isn't just about lift. It's also about stability and control. Planes capable of inverted flight have specific design features, and the pilots undergo extensive training to ensure they can maintain control and safely return the plane to normal flight, emphasizing the importance of both the aircraft's design and the pilot's skill. And here's the surprising part. Even when a plane is flying upside down, it still needs to stay stable. It's like driving your car in reverse. You need to keep an eye on where you're going to avoid crashing into something. Pilots have to be extra vigilant, constantly adjusting the controls to maintain stability and prevent any unwanted movements. Now, let's talk about some of these design features. One key element is the aircraft's center of gravity. It needs to be carefully positioned so that the plane remains balanced even when inverted. Imagine a seesaw. If it's not perfectly balanced, it tips over. Planes are designed with similar principles in mind. And here's another fun fact. Some planes have special control surfaces that can adjust automatically during inverted flight. These are like emergency brakes or steering systems for your car, just in case the pilot needs to quickly correct any drifts or unwanted movements. But remember, these features only enhance what pilots already know how to do. Flying upside down is not a one-person job. Pilots also undergo specialized training to handle inverted flight. They learn to maintain their focus and stay calm under pressure, just like you might practice breathing exercises in a stressful situation. The training helps them handle the unexpected and make quick decisions to keep everything running smoothly. So, while flying upside down sounds cool and maybe even a bit scary, it's all about control and design working together. It's not something you'd find on every plane, but for those that can do it, it's a testament to both the ingenuity of aircraft designers and the skill of their pilots. So, why don't we see planes flying upside down very often? It's not just a cool trick, it's actually pretty impractical in real-world aviation. First off, let's think about it like this. If you were driving your car backwards on a highway, would that be safe or practical for everyone around you? Exactly. The same goes for flying planes upside down. Air traffic control and other aircraft wouldn't find it easy to predict where an upside-down plane might go next. And here's the surprising part. Commercial pilots undergo very rigorous training to handle all kinds of situations. But in real life, flying upside down is incredibly rare because it's not what we need to do on a typical flight. In fact, most pilots will never have to perform this maneuver during their entire career. Now, imagine you're in the plane and suddenly hear, "Okay, folks, we're going to flip upside down now." That wouldn't exactly make for a smooth ride, would it? Safety is always the top priority. Commercial airliners are designed to handle all sorts of maneuvers safely, but flying upside down just isn't one of them. But here's something that can reassure you. Even if an emergency situation were to arise where such a maneuver was necessary, pilots are well trained for those kinds of scenarios. The plane is incredibly safe and reliable, thanks to years of development and testing. And so, while the ability to fly upside down might seem like a neat trick, it's more of a rare demonstration or movie stunt than something you'd see in everyday commercial aviation. It just goes to show how adaptable and capable these amazing machines are, despite being highly engineered for safety and efficiency. So, to fully answer our initial question, planes can indeed fly upside down, but it requires specific conditions, aircraft design, and pilot training. This capability, while not commonly used in everyday flights, showcases the remarkable flexibility and safety of modern aviation. Imagine you're playing with a toy car. Most of the time, it drives forward on the ground. But if you have the right car and skilled hands, you can even make it drive upside down for a bit. That's kind of like flying an aircraft upside down. It takes special planes, expert pilots, and precise maneuvers. For example, some fighter jets are designed with certain features that allow them to fly inverted safely. But in commercial aviation, the planes aren't built for this. They're optimized for efficiency and safety during normal flights. If a passenger jet were to try an upside-down maneuver, it would be incredibly rare and risky. In fact, the ability to fly upside down is just one of many incredible capabilities that modern aircraft possess. These marvels of engineering are constantly pushing the boundaries of what's possible in aviation, ensuring that flying remains safe and reliable for everyone who boards a plane. If you found this explanation fascinating, consider subscribing for more insights into the world of aviation and how flying really works. Who knew there was so much going on behind the scenes?